Organizations spend millions of dollars building heavy back-end security, firewalls, strict zero-trust architectures, and resting data encryption. They treat their servers like modern fortresses. But attackers rarely waste their time drilling through 2 feet of solid steel. If the server is locked down, they bypass the server entirely. They target the user. The web runs on HTTP, or Hypertext Transfer Protocol, a system with absolute amnesia. It treats every single click, page load, and form submission as a completely new, unrecognized visitor. To solve this amnesia problem, the web uses a session cookie. A session cookie is a temporary piece of data stored in your browser that tracks your identity. When you log in with your password, the server sends back this glowing digital VIP pass. Now you don't have to re-enter your password every time you click a new link. The convenience creates a massive blind spot. The server blindly trusts the cookie itself. It has no way of knowing who is actually holding the VIP pass. If an attacker manages to steal that specific digital token, the server will treat them as the authenticated user. True vulnerability lies in tricking the system into granting a valid session. Attackers do that by offering the system a poisoned apple. This often begins in a seemingly harmless, public-facing part of a target website, something like a user forum or a comment section. An attacker approaches this comment box. Instead of typing a normal text response, they write and submit a string of malicious JavaScript. JavaScript is the programming language that makes web pages interactive and dynamic. This works because of an input validation failure. Input validation is the process of verifying that incoming data is safe and meets expected formats. Here, the application makes the mistake of blindly trusting the user's text, failing to check if the input contains executable commands. In this diagram, you can see the exact moment the trap is set. The backend database shares this malicious script exactly as written. It permanently stores the trap within the website's own trusted architecture, right alongside normal, safe data. The server itself is now unwittingly hosting the attacker's weapon. The poisoned apple is sitting on the table, waiting for a high-value target to take a bite. Now the victim arrives. An administrator with high-level access logs into the site, receives their highly privileged session cookie, and naturally navigates to the infected forum page. The server receives the request, unknowingly pulls the poisoned comment directly from the database, and serves it to the administrator's browser. This representation of the browser's architecture shows exactly how the execution phase happens. Browsers are designed to execute code seamlessly. While the admin reads what looks like normal text, the browser reads the malicious JavaScript hidden in the comment and blindly obeys it. This technique is cross-site scripting, or XSS, an attack exploiting HTML pages, allowing scripts to run alongside standard data. The injected script accesses the browser's storage, gathers the VIP pass, and silently transmits it to the attacker. The admin sees absolutely nothing unusual. The attacker receives the stolen cookie on their end. They inject it into their own browser session and simply refresh the target website's page. The attacker now holds full administrative control. They completely bypassed the organization's multi-million-dollar perimeter security, and they never had to guess a single password. Front-end trust vulnerabilities render back-end encryption and perimeter defenses useless. If the front door grants access to anyone who asks, the thickness of the vault door doesn't matter. To neutralize this threat, developers use a mandatory defense strategy: input validation and output encoding. As you can see in this filter mechanism, applications must enforce strict sanitization rules. Anything typed into a comment box is intercepted, stripping away its executable tags. The code is treated strictly as inert text before it ever hits the database. The second essential layer of defense secures the session token itself using the HttpOnly cookie flag. HttpOnly is a security setting preventing client-side scripts from accessing cookie data. Setting this flag acts as an architectural command to the browser. It physically blocks any JavaScript, even malicious scripts that slip through the cracks, from reading or touching the session cookie. Modern cybersecurity requires verifying every single piece of data allowed inside the gates and protecting the session long after it has been authorized.